Hola, hi, this is Al Nosdal, your probability and statistics instructor. As you can imagine, it is time to start doing some probability. Here we go. What I would like to do today is introducing a very important concept in probability theory called expected value or expectation. It's also known as expectation or the mean of a random variable. Okay? So in order to introduce that important concept, I would like you to solve a problem with me here in this short video. Okay, so we are going to use a game of chance so you can clearly see what's the idea behind the concept of expected value. Okay, so most states in Canadian provinces have lotteries. Okay, the example that I chose here is a simple lottery wager from the Tri-State Big 3 game. This is a game that New Hampshire shares with Maine and Vermont. Okay? The important thing is this, how the game works. It works as follows. You choose a 3-digit number. Okay? And then the state chooses a 3-digit winning number at random. Okay? And if the state chooses your number, then the state is going to pay you $500. Okay? But that is going to happen only if your number is chosen. Okay? You get $500. Now, after what we have been studying lately, right, now we know a few counting techniques, right? So it must be clear for all of us that there are 1,000 3-digit numbers, okay, that could result from this random experiment. And let's convince ourselves that that's the case, that there are 1,000 3-digit numbers. So we said that we are drawing 3-digit numbers, right? So how many choices do we have for the first digit? 10, 0, 1, 2, up to 9, right? 10 possibilities. Now for the second position, for the second digit, we have another 10. For the last position, the third one, we have another 10. So 10 times 10 times 10, that's 1,000, right? Okay, so since these numbers are chosen at random, each of these 3-digit number sequences has the same probability of being the one actually chosen, right? So we have, if we purchase just one ticket, a probability of 1 in 1,000 of winning. Okay? Now, we are going to define a random variable y. Okay? The random variable y is going to represent the amount of money your ticket pays you. Okay? Okay. So again, remember that the random variable is a function that takes you from the sample space to the real numbers. Okay. What we would like to do with this random variable is this. We would like to find its probability distribution, and we would like to find the average payment from many tickets. Got it? Okay. So we know that the probability distribution of a discrete random variable y is just a mouthful for the list of all possible outcomes with the corresponding probabilities. So y could be 0, meaning you don't get anything, right? You don't get a payment. Or, hey, y could be $500. Now, so y equals 0, y equals 500. Those are the possible values that this random variable could assume, right? Let's find their probabilities. So the probability of getting nothing is, well, what happens most of the time, 99.9% of the time, or since we're using 1000 here, well, 999 divided by 1000. If you bought 1000 tickets, right, your probability of getting nothing would be, 999. Now you are going to win only if you choose the right one, the same number that the state chose. So that's only 1 out of 1000. And then we know that a legit probability distribution must satisfy two conditions. Condition number 1, these probabilities here must be numbers that live between 0 and 1. That is the case for both of them. Next property, when you add them up, all of these numbers that are part of the probability distribution, we should end up with a 1, with a total of 1. And in this case, it's clear that we end up with a 1, and it's clear that those two probabilities are numbers that live between 0 and 1. So we're dealing with a legit probability distribution. We seem to be on the right track. Okay, B. Find your average payment from many tickets. So, let's think about this. If we purchased 1000 tickets, right? Only one of them is going to be the winner, right? That's a probability of being of choosing the winner. And then if you choose that guy, well, then you get $500. On the other hand, 999 out of 1000 times, you get nothing. So if we do the math here, what you end up here is with 0.5, right? So that would be your average payment from many tickets, right? That's what you would get if you bought, in this case we said 1000 tickets. Convince yourselves that I mean, if you repeated the experiment 10,000 times or whatever, then same thing goes. Make sense? Okay, so what I want you to see here is the meaning of this number that we just found. That number is the mean of the random variable y. And that's what we also know as the expected value of y. Note something else. The tickets cost $1. So in the long run, the state keeps half the money you wage, right? So it seems to be a profitable business. Okay? So bottom line, what this concept is, the concept of the expected value is just the average, but it's a very special kind of average. It's a weighted average, and the weights that we have here are given by the probabilities for each of these possible outcomes. So for instance, if I wanted to write down this using notation, this is what I would do. Expected value of random variable y would be the possible value that the random variable, it would be the possible value that the random variable could assume times the probability of the random variable being that. Same goes for the other one. 0 times the probability of y being equal to 0. Right? So the shorthand notation that we're going to have here is this. We're going to be using that sigma notation, and it will look something like this. Y times the probability that the random variable y assumes the value lowercase y. Make sense? That's a formula that we're going to have for discrete random variables, and this will be for all. This sum will be done for all possible values of y. Make sense? Okay, so in the near future we're going to be computing expected values for other random variables, but the main purpose of this example was showing you what's the idea behind an expected value. In this case, it would be your expected, from your perspective, if you're purchasing a lottery ticket, is your expected gain. From the from the perspective of the state, this would tell them how much they have to charge someone to play a Tri-State Pick 3 game, right? That's the minimum amount that they have to charge in order to not lose money. Make sense? Okay, well, that's it for now. Thank you so much. Please take care and keep working hard. See you next time. Bye.